OMG, you guys. Miss Kujawa just did this whole lesson and she didn't even hit record. I mean, I thought I hit record, but it didn't really go through. So here's round two. That's really frustrating, and I'm going to take Pete the Cat's advice. Am I going to cry? Goodness, no. I'm going to keep walking along, singing my song. I am recording on Easter, and I have a lot to be thankful for. So, hi! Welcome. It's Monday in your land when you'll be watching this, and I hope you guys had a really good Easter filled with family, food, and fun. We're going to hop into this lesson for my second time. I'm going to be really good at triangles by the end of this. Okay, well, we are getting into the actual shapes part of geometry. I know we couldn't get into that in the classroom quite yet, but here we are, ready or not. Let me see, I have all my slides ready. When you think of triangles, you probably think of, oh yeah, standard triangle, Miss Kujawa, I know what a triangle is. We're going to really dive deep into the different kinds of triangle. First of all, did you know that tri means three? Like a tricycle has 3 wheels. Triangle has 3 sides. So we're going to get into all different types and kinds of triangles. We're going to be first classifying our triangles by the angles. We have a right angle, which by definition is in exactly 90 degrees. Every time you see, or anytime you see, that little box, that should trigger you to let your brain know, hey, that's 90 degrees. All right, then we have an obtuse, and obtuse means that it is bigger than 90 degrees, and it kind of makes that obtuse rainbow kind of shape. And then an acute is really tiny. It's less than 90 degrees, and it's really cute, and that's why I like to call it an acute triangle. That's something that helps me remember. So every time we see these angles, I'm going to slide this up. When they enclose that figure, it makes that type of polygon, so it's a right angle triangle, an obtuse triangle because it has that greater than 90 degrees angle, and an acute triangle because it's really cute. It's less than 90 degrees. Alrighty, that's one thing. When we will classify a triangle, we're going to be looking at those angles, and then the other way to classify it is to look at the sides. So here's a little guide for us. We have an equilateral triangle, and when you hear the word equilateral, I hope the word equal kind of makes your ears ding. And when you hear equilateral triangle, I want you to remember that all 3 sides are equal. That's why it's called an equilateral. The next type of triangle is called an isosceles triangle. There are 2 E's in isosceles, and we have 2 I's I could see with my eyes. And there are 2 triangles that are both equal. So whenever you see the 2 E's, that's how you know that there are 2 sides, and it's called isosceles. The next one is a triangle that has absolutely no sides that are equal, and that's called scalene. It's not even on the scale. None of them are the same. All right, we're going to hop into our lesson for today that I just taught. It's okay. I'm going to stay positive and maybe not remind myself. But you guys are working out of your Pearson. You're going to do the evens with me. Work on the odds on your own. Don't forget to put your name, date, number on it so I can give you that credit. And we're going to first look at that first one. Okie dokie. So again, the first thing that I want to take a look at is the angles. Ooh, I see that trigger little square box thingy, and I know that triggers my brain to let me know that that's a right angle, which means it's going to be, let's use this one, a right triangle. Now, writing the word right, which means it's a right triangle, is only one way to classify the triangle. We also have to look at the sides. So we do know it's a right triangle, but now let's take a look at our sides. We have 4 inches, 3 inches, 5 inches. Are any of those equal? No. It's not even on the scale. It's a scalene. But it's not just a scalene, it's a right scalene. And that's what you put on your line. It's a right scalene triangle. And that's it. We're going to keep going with our triangles, but there's no computating any of the numbers. We're just trying to identify and classify what kind of triangle it is by looking at the angles and the sides. Let's go to the next one. Keeping those angles in mind, boom, I see that trigger right angle box, so I definitely know right off the bat, get it? Right. It's okay. It's a right angle kind of right triangle, but now I need to look at the sides. We have 14 meters, 19.8 meters. Ooh, two of those are equal. And when two of those are equal, think you have two I's and there are two E's. So you can see, that it is a isosceles. And we're going to check to make sure that we spell this right. Alrighty. Moving right along to our next triangle. Again, we are going to check out the angles of this triangle. We have a 35 degrees, 70 degrees, 75 degrees. Those are all so cute. They're less than 90 degrees, and I just like to pick out the cutest of the one. So we are going to write acute. But now that we classified the angles, we got to classify what kind of triangle it is based on the sides. We have 8 centimeters, 5 centimeters, and 8.2 centimeters. None of those are the same. None of those are equal. So when none of those are equal, it's not even on the scale. Makes it a scalene. And that's what we're going to put. So this whole triangle is an acute, but also scalene. All right, let's go to number 8. Taking a look at the sides. Nope, angles first. We have 70 degrees, 70 degrees, 40 degrees. Again, those are all less than 90 degrees, so they're all very cute. That's my cutest of the angles. So I am going to write acute on the line. And now let's take a look and check out the sides. Sorry guys, remember, I've done this twice now. So we have 3 meters, 3 meters, 2 meters. And again, I see 2 that are equal. And when 2 sides are equal, it is an isosceles. So we're going to write isosceles. So again, this was a right triangle, but isosceles. This is an acute triangle, but isosceles, because we want to classify them by looking at the angles and the sides. Alrighty, moving down here, I'm going to zoom us down. We're going to take a look at those angles. Now, on your paper, there are no angles, and actually, this was one of your word problems in your Pearson. So I'm going to slide this to the next page. It says that Judy bought a new tent for camping trip. Look at the side of the tent with the opening. Classify the triangle by its sides and its angles. And this is what they give you. They give you this little tent right here. And I just kind of drew that on there. So there are no angles, but by using the knowledge that I've learned from today's lesson, if I were to look at my angles here, I don't see any red boxes or any like right angles that will trigger me and show me that this is a right angle. And if I look at obtuse, though obtuse is really wide, these are all acute. These are all less than 90 degrees. So I definitely know that it is an acute triangle. Then I have to figure out by looking at the sides what kind of triangle this would be. We have 4 feet, 4 feet, 3 feet. And again, 2 of those are equal. And like there's 2 E's in isosceles, that helps us to remember this is an isosceles triangle. And I'm going to look over there to help me with my spelling. Isosceles. Alrighty, sliding over to number 12. Number 12 is also another word probs. We're looking at a dude named Ted. It says, Ted says that the triangle below cannot be classified because all the sides are different lengths. Is Ted correct, and explain why or why not? Well, if all the lengths are different, isn't that the name of a triangle when they're all different, when none of them are equal? If none of them are equal and they're not even on the scale, that means it's a scalene triangle. So to answer your question, Ted, no, you're not correct. Because triangles, I'm going to kind of draw the shape, that have no equal sides are called scalene. Called scalene triangles. And I'm just going to extend my little written line there. Alrighty, it's our last one. I can't believe it, although, like I said, I've done this before. But moving right along here. You might be thinking, why is there triangles and then there's a multiplication? Well, it's good spiral review. We got to keep our brains fresh. It says a factory ships widgets. What's a widget? In crates. If you can Google and do some research and tell me what a widget is, I'll give you some extra credit. Alrighty. There are 12 boxes in each one of these crates. Okay, so this is the whole crate right here. And here's all the 12 boxes. Each box holds 275 widgets. How many widgets are in one of the crates? Each is another trigger word, speaking of trigger. And that tells us that we need to multiply. Because if there are 12 boxes and each of them have 275, we got to multiply to see how much the entire crate of widgets there are. So I'm going to use some fun different colors down here. And I'm going to zoom us in. Alrighty, let's start with this 2. 2 times 5 is 10, so we're going to put down our 0, carry up the 1. 2 times 7 is 14, plus 1 more makes it 15, so we're going to put down that 5, carry up the 1. 2 times 2 is 4, but plus 1 more makes it 5. All right, if you got that for your first row, that is awesome. But before we go to the next row, we do have to add our little placeholder. And as another good strategy is to cross off any of the top numbers so that we don't get confused. I'm going to go with the green color. All right, it's the 1's turn. Oh, we're going to throw that green color away. Let's try this green color. 1 times 5 is 5. 1 times 7 is 7. 1 times 2 is 2. And you just gotta love math like that. Alrighty, keeping our Julian method in check, we're going to add that little invisible 0 just to keep things interesting, keep them even. 0 plus 0 is 0. 5 plus 5 is 10. We're going to put down the 0, carry up the 1. 7 plus 6, well, I know 7 plus 7 is 14. So if I just take 1 away because it's 7 plus 6, that's 13. So that's some little logic for me here. And then 2 plus 1 is 3. So in this entire one crate, there are 3,300 widgets. And again, I'm interested to see who can tell me what a widget is. All right, you guys, thanks for tuning in with me. I'm going to have to do some editing here for the videos because I did a couple of them. But I hope you guys have a great day. I'll see you on Zoom. And as Ellen always says, be kind to one another. Bye, guys.